Find the highest common factor of 60 and 84. So the first thing we're going to do is make a factor tree for 60 and 84. So what I mean by that is I'm going to start with 60 and we're going to branch off and look at some factors. So what two numbers multiply together to get 60? Well, we can get 2 and 30 would work. And as soon as we reach a prime number, we know that branch has stopped. So here we can see 2 is a prime number. So this branch has stopped and I'm going to put a circle around it. But because 30 isn't a prime number, this branch is going to carry on. Okay, so factors of 30. Okay, we could have 2 again and 15. Cool, so this branch has stopped because we got a prime number. But 15 we can carry on. So we can have 3 and 5 there because 3 multiplied by 5 gives us 15. And now both of these are prime numbers, so we'll circle them. And we see we've got no branches to carry on, so we're all done. Now let's do the same thing for 84 over here. I'm going to split that off into 2 and 42. So we're going to circle the 2 here. And 42, okay, well, we can split that into 2 and 21. And lastly, we'll get 3 and 7, which are both prime. So we're done. So what this tree has told us is that 60 is made up by multiplying 3, 5, 2, and 2. And the same way for 84, it's made up of 7, 3, 2, and 2. So now to get the highest common factor, we're going to work out what is common in each prime factorization. So you see we've got a 2 here. And if I found it in 60, I need to look, is it in 84? Yeah, so I'll cross that off. So for our highest common factor of 60 and 84, we're going to have a 2 in there. Now we see, oh, we've got another 2 here that's common to both of them. So we're going to multiply by 2 again. And I see, well, I've got 3 here and 3 here. So we can multiply by 3. However, I can't do anything with this 5 because that's only in this prime factorization, not over here. And there's only a 7 here, not up here. So now we're done. So we've got 2 multiplied by 2 multiplied by 3, which equals 12, which is the final answer. So we get our first mark up here for our factor trees, and our second mark for the correct answer of 12. Now part B wants the lowest common multiple of 24 and 40. So again, for this question, we want to create our factor trees. So starting with 24, we can split that off into 2 multiplied by 12, and 6 multiplied by 2, and 3 multiplied by 2. Now, one thing I just want to point out is you can split it up however you want. We can split it here as 2 and 20, because 2 multiplied by 20 is 40. However, you might also be thinking, we could split up as 4 and 10, and that's absolutely fine. We'll end up at the same point however you split it up, so just split it up however's easiest for you. So now in this case, we're going to have 2 and 2, and 2 and 5. So now we need to work out the highest common factor first in the same way we did before. So I've written out our prime factorizations. So the highest common factor of 40 and 24, we're going to look for our pairs. So I've got 2 here and here. So we've got a 2, 2 here, 2 here, and 2 here, 2 here. So it's going to be multiplied by 2, multiplied by 2. And that's it, because we haven't got any more pairs out of these numbers. Meaning our highest common factor is 8. Now the lowest common multiple of 40 and 24 equals our highest common factor, which is 8, multiplied by the numbers we had left. So multiplied by 3 and multiplied by 5. And doing that, we get 120. So again, our first mark comes from the factor trees up here, and the second mark for the final answer of 120.